distinguished dignitaries and honorable invitees, my dear colleagues and friends from PRL and SAC, ladies and gentlemen, good afternoon and a warm greetings to all of you. I hope all of you are comfortably seated and temperature is comfortable. Well, at the outset, I'll request all of you to kindly switch off your mobile phones or turn them onto silent modes so that we can have our proceedings uninterrupted. As you all know, today is yet another milestone event in the history of PRL. That this is the 75th Vyakhyaan in the Vyakhyaan series. And many of you are aware that as part of this Vyakhyaan series, a precious wealth of information and knowledge has been gathered and archived. I'm not going to tell much about the Vyakhyaan. You will hear more in detail in time to come. But we shall begin today's proceedings with lighting of lamps, which has been a part not only of the Indian culture, but that of many other cultures across the world. Because fire represents luminescence and brilliance, and lighting of lamp symbolizes dispelling the darkness and ignorance. So that is what we are going to begin this event with. So at the outset, I'll request our director to kindly accompany the distinguished dignitaries. First of all, Padma Shri A.S. Kiran Kumar ji, Professor Himanshu Pandya, Vice Chancellor of Gujarat University, Dr. Sumer Chopra, Director, Institute of Seismological Research. We are also fortunate that we have with us two of the Vyakhyaan Kartas who have delivered the Vyakhyaan in the series. So we have Dr. Shishir Deshpande. May I request Shishir, please, to kindly light the lamp. And Dr. Vishnu Bhai Pandya. Well, I was under the impression that lighting of lamp is only part of Indian culture, but I realized that the same practice is followed in many other cultures in the world, not only in this part, but in the temperate and polar region as well. Thank you very much. May I now request Professor Anil Bhardwaj, Distinguished Professor and Director of PRL, to formally welcome the distinguished dignitaries and our honorable invitees. Professor Bhardwaj, please.
नमस्कार, सुअपराहन, केम छो, आदाबार्स, खम्मागनी, वनकम, सत श्री अकाल, very good afternoon, or good morning, or good evening, depending upon which part of the world you are joining live on the PRL's YouTube channel. आप सभी का PRL के अमृत व्याख्यान में स्वागत है, अभिनंदन है। श्री A.S. Kumar जी, Chairman PRL Council, distinguished invitees and guests, colleagues from SAC and PRL, and ladies and gentlemen. A very, very warm welcome from me, Anil Bharadwaj, for the PRL ka Amrit Vyakhyaan. It is indeed a great pleasure for me to welcome all of you for the today's Vyakhyaan, the 75th Vyakhyaan, or the 75th PRL ka Amrit Vyakhyaan. We started the PRL ka Amrit Vyakhyaan series of 75 episodes to celebrate the Platinum Jubilee of PRL, and it all started on 4th of August 2021, on Wednesday, since the colloquium day of PRL used to be on Wednesdays. And it was started online due to the COVID, but that became a boon because online we were able to contact and get the Vyakhyaan Kartas from across the globe. So this PRL Kamrit Vyakhyaan is essentially meant to celebrate the 75 years of legacy and history in fundamental physics and space sciences. PRL, which is established by the father of Indian space program, Dr. Vikram Sarabhai, in the year 1947, also coincides with the India's 75 years of independence. So as we celebrate Azadi Ka Amrit Mahotsav, we also celebrate Platinum Jubilee of PRL. Hence, you can say it's a joint celebration of the development of science and technology in India by PRL under the banner of PRL Ka Amrit Vyakhyaan. Every Wednesday at 4 p.m., we are having the Vyakhyans online, uninterrupted, except on certain occasions due to the working time of the colleagues in other countries, more particularly like in US, Europe, or Australia, or Japan. We had to shift the timings, but dates were kept same. Or we had a shift of a day, like today, for example, it is Thursday, not Wednesday. Or on a day when it was Diwali, and we had to shift it by a day because nobody will like to have a PRL Amrit Vyakhyaan on a Diwali day. The successful completion of a marathon series of 75 Vyakhyans, including today's Vyakhyaan, has been possible by the hard work and the commitment of the PRL Ka Amrit Vyakhyaan Committee, chaired by Professor Nandita Srivastava from Udaipur Solar Observatory, who has joined us live. Nandita, I hope you may be hearing us. The co-chair, Professor Lokesh Sahu, and 7 members of the PRL Ka Amrit Vyakhyaan Committee. May I now request all these members of the PRL Ka Amrit Vyakhyaan Committee to please stand up at their locations so that, no, not you, only the members of the PRL Ka Amrit Vyakhyaan Committee, so that we can clap and acknowledge their contributions. It was because of the splendid efforts by this committee that we had uninterrupted, successive 75 episodes. These 75 Vyakhyans, including of course today's Vyakhyaan, has been delivered by the 75 distinguished personalities covering the domain of science, technology, engineering, arts, literature, sports, medicine, law, business, management, history, and entrepreneurship. And also includes Vyakhyaan Kartas from outside India, as I was just mentioning. All the PRL Kamrit Vyakhyans have been live telecasted, including the today's Vyakhyaan, on the PRL's YouTube channel. And that gives an advantage for those who can join live, or for them, if they are not able to join us live, to see them later at their convenience. So far, excluding today's Vyakhyaan, we have more than 25,000 views of the YouTube channel of PRL for the PRL Kamlesh Vyakhyaan. My colleague, Professor Nandita Srivastava, will give you some more statistics about all the Vyakhyans which has happened. And we will also see the efforts the committee has put in to conduct this in a very instinct manner. So today is the completion of the 75th episode of the series of Vyakhyans. And this milestone Vyakhyaan, for this milestone Vyakhyaan, we have with us Padma Shri A.S. Kiran Kumarji, Chairman PRL Council, and of course he has many other hats which my colleague Professor Pallam Raju is going to describe to you his brief biodata. Otherwise he has a very expanded biodata which is not possible to be given in few minutes. And we are really fortunate, and we really thank and appreciate Shri Kiran Kumarji coming over to PRL and to deliver this Vyakhyaan in person, because he says, I will not give you Vyakhyaan online, I want to come to PRL to give you the Vyakhyaan. So, and he is going to give a Vyakhyaan on the most apt topic, and the topic is Vikram Sarabhai and the Indian Space Program. So as we celebrate PRL 75 years, the institute established by Dr. Sarabhai, and PRL known as the Cradle of Space Science in India because all the space science activities started in PRL. We are going to hear from him how ISRO or Indian Space Program is connected with Sarabhai and how this whole legacy started. Before I close, let me also announce that today is not the last Vyakhyaan. Today is only the completion of the 75th PRL Kamlesh Vyakhyaan. The PRL Kamlesh Vyakhyaan has attained a status, as you will hear more details from Nandita on it, and hence we have decided that henceforth we will continue to have the PRL Kamlesh Vyakhyaan, but not every week or every Wednesdays, but once in a month. And so that when we celebrate the centenary of PRL in the year 2047, we will have more than 350 PRL Kamlesh Vyakhyaan completed by then. So with this, let me once again welcome everyone joining us live in this hall and those who have joined us live on the PRL's YouTube channel to celebrate the 75th Vyakhyaan and to celebrate the Platinum Jubilee of PRL. Dhanyavad, thank you.
Thank you very much, Professor Bhardwaj, for your welcome remarks. He mentioned everything, but he missed to mention one thing, and which I know he would not mention, but I will have to mention, that ideas are more important than individuals. And the whole idea of having such a wonderful collection of 75 talks, that was his idea. We are running this idea which he thought. So I think big hand is also due for him. And another important thing that all these Vyakhyans are listed, the speaker's topic, the biodata of the speaker, everything is listed on PRL's website. So you may wish to have a look at it. And they are all on the YouTube channel of PRL, so you can have a look at all these Vyakhyaan at any time that you like. Thank you so much. So the next is, we'll request Professor Nandita Srivastava from USO. And it will take about 30 seconds for them to get in touch with her. And Professor Nandita is senior professor at USO.
Can you hear me?
And are you able to? Yeah. Okay. Can you hear me, Nandita?
Yes.
Great. Thank you. So Professor Nandita Srivastava is here. She is the chairperson of Vyakhyaan committee, and played a very important role. So I request you to present the summary of this Vyakhyaan. Over to Nandita.
Thank you, Professor Deshpande. Can you see my slide?
Well, we can see you, but not really your slides.
Not yet?
Not yet.
Just a second.
Anything is to be done at this end? Nothing. No? Yeah. So Nandita, maybe you can try. You'll be able to present. Yes, it's coming. Yes, we could get it.
Okay.
Yeah, that's
Good
fine. We can
afternoon,
see.
everyone.
Yeah.
Good afternoon, everyone. As part of PRL's Platinum Jubilee celebration, we have organized the PRL Ka Amrit Vyakhyaan. You have already heard. This series began on 4th of August 2021 and continued for 75 weeks. Today, on 5th of January 2023, we have reached the most significant milestone of the 75th Vyakhyaan. And as mentioned earlier by Professor Bharadwaj, PRL's Platinum Jubilee celebration coincides with the 75 years of India's independence, and therefore we celebrated this event as part of Azadi Ka Amrit Mahotsav launched by the Government of India. To this end, we set out to invite people of international repute to learn about the contemporary developments in different fields around the world. When we began this series on 4th of August 2021, we were still coming out of the worst phase of the second wave of COVID pandemic. So I think in my view, one positive aspect of this pandemic was that it leveled ground for everyone. It also helped connect people at remote places in online mode as I'm connected now. So PRL Ka Amrit Vyakhyaan stands as a testimony to this in bringing PRL members, its alumni and other viewers closer in the pursuit of sharing knowledge and experience. So I would like to share the summary. This is a summary of Vyakhyaan speakers, and I show you the country-wise distribution. We had speakers from 11 countries. Of course, India is dominating here. It is natural for us to invite Indian speakers for our Platinum Jubilee celebration as well as for India's Azadi Ka Amrit Mahotsav. All the invited speakers have been the shining stars of the galaxy of Amrit Vyakhyaan. They have achieved great heights in their respective fields, and they were leaders and directors of institutions and observatories in India as well as abroad. We also had a talk from Director VSSC, Shri S. Somanathji, who is now the Chairman ISRO. We had Director General of NDRF and also a talk from Judge of Supreme Court of India. So they are also very distinguished, as Professor Bharadwaj already pointed out. They were speakers from national and who won national and international awards of excellence, including Padma awardees, fellows of science academies in India, fellows of Royal Society, and also Nobel laureates. So in this, we had 3 Nobel laureates, 2 in physics and 1 in chemistry. We covered a large number of topics, broad categories that we can define here is by shown in this plot. Mainly we concentrated on scientific research, and then this was followed by lectures in medicine, and that was to remind us that COVID is not yet over. We had lectures on technology and innovation, scientific policies, sports and adventure, Hindi literature, business and management, library science, and law. So these talks were focused on the problems that we are challenged with, and I have listed some of them here. Not all could be covered in one slide. So like the present challenges of climate change, space weather, their societal and economic impacts, socio-economic benefits from Earth system, geotrace and biogeochemistry, and groundwater resource use in India, and even urban transport. We had a large number of lectures in medicine. and they highlighted that prevention in health is wealth. We also had talk on COVID-19 opportunities and challenges, and also we had a talk on development of new generation antibiotics, which is more eco-friendly. So there were talks on astronomy as well, on exoplanets, asteroid research, astrosat results, infrared and radio telescopes, and their results that we have obtained till now. We had Vyakhyans on India's fusion research, dark matter, particle and quantum physics research. Of course, we should also mention about the space lectures that we had, and they covered India's journey in space, human space flight program, space laws that are in making, Vikram Sarabhai and his vision. Apart from these broad science and astronomy and the topics, we also covered sports and in particular the role of sports in nation building, Everest expedition, and we had a talk in Hindi about Meri Bhasha Mera Desh. We covered the library science open access in astronomy, basically utilizing the information that we gain through our research and disseminating them to the researchers all over the globe. So these are the stars of the and we have, you see, it's a very bright galaxy with illuminating stars. We had women speakers in PRL Ka Amrit Vyakhyaan. During February and March 2022, we had several talks, starting from the International Day for Girls and Women in Science on February 11th to International Women's Day on 8th March. There were about 6 speakers. We celebrated the achievements of women in diverse fields by hosting lectures in the fields of sciences, sports, and arts, and some of them are listed here. In this included the Biba Chaudhary Memorial Lecture, National Science Day, and there were others who participated and gave talks by Dr. Gagandeep Kang, Annapurni Subramaniam, Ashwini Nachappa, Mallika Sarabhai, and Lalitambika and Uta Grotkov from Germany. So these are these women are provided us fascinating insights basically into their outstanding work and their journey, and they not only serve as role models for women but for the entire humanity. So here are the women speakers, as you can see in the yellow highlighted frames. I am also pleased to inform that that these 75 Vyakhyans were watched by approximately 25,000 people on YouTube and WebEx, which I think already Professor Bharadwaj has highlighted. We naturally followed a Vyakhyaan calendar. We were celebrating different events and milestones. These included Vikram Sarabhai Jayanti, National Engineers Day, Foundation Day of PRL, Foundation Day of Udaipur Solar Observatory, and we celebrated World Space Week by inviting Vyakhyaan from space research area, anniversary of Mangalyaan launch, Dr. Arvind Bhatnagar Memorial Lectures, which was initiated last year, Dr. Biba Chaudhary Memorial Lecture, about which I just mentioned in the previous slide, International Yoga Day, National Doctors Day, and the World Environment Day. So you can have an idea of how many topics we covered on different events and different milestones or days that we celebrated all along since August 2021. And these are the special event speakers which have been highlighted in red frame. These are the Nobel laureates that we invited in PRL Ka Amrit Vyakhyaan. We had Professor Ada Yonath from Israel. She is the first woman from Middle East to win a Nobel Prize in biochemistry and biosynthesis. So the Nobel Prize was awarded to her in chemistry. We had Professor Michel Mayer from University of Geneva, Switzerland, in exoplanet research. He received 2019 Nobel Prize in Physics. and Professor Anthony Leggett, who got the Nobel Prize in Physics in 2003. So, towards the end, I would like to say that I am actually humbled by the fact that when we approached these speakers, all of them instantly agreed to be a part of our Platinum Jubilee celebrations. I owe this to the charisma and prestige of our founder, Dr. Vikram Sarabhai, whose reputation and legacy as the father of Indian space program continues to inspire the entire nation. The speakers generously agreed to give their talk and also agreed to record and stream online on YouTube. Each Vyakhyaan was an hour-long lecture followed by a close interaction session of the speaker with the participants. These sessions were very lively and very illuminating. As has been pointed out earlier, these lectures have been archived and are available at PRL website, and I think it will serve as a treasure trove of PRL for future. In fact, we consider our each Vyakhyaan of our Amrit Vyakhyaan series as a jewel in the crown, which will remain as PRL's prized possession. On behalf of Director PRL and my colleagues, I would like to thank each and every Vyakhyaan speaker for generously giving their invaluable time to us and sharing their vast knowledge, wisdom, and experience with the audience. This has left us enriched with knowledge, broadened our horizon, and rejuvenated us to keep pace with the recent developments in the diverse fields. Lastly, I would like to express thanks to members of Amrit Vyakhyaan Committee, including the co-chair, Professor Lokesh Sahu, and convener, Dr. Bhushit Vaishnav, and Dean PRL. Thanks to the entire team, I think we managed to sail through this Herculean task like a family week after week. In the end, I would like to particularly thank Professor Bharadwaj for giving me this opportunity and being the driving force of this activity throughout the year. So thank you very much.
Thank you very much, Professor Nadita, for an excellent overview. It ran through all 75 episodes, and I am sure you must be relieved of the tension which you had every Wednesday, because, in spite of this high-tech edge, in the morning at 11 o'clock you do trial, everything is perfectly fine, and 3 o'clock it won't work. And the worst part is that people from across the globe are watching this, so if it goes bad, it doesn't look good. So, but in spite of that, we have done everything nicely. Congratulations to you, and thank you very much.
Thank you.
Good. So now we have to move ahead towards the Vyakhyaan, next Vyakhyaan, for which all of us have gathered. But before we listen the Vyakhyaan, I will request Professor D. Pallam Raju to introduce the Vyakhyaan Karta today. As such, we all know Vyakhyaan Karta, and there's no need for introduction. It's like using torch to show where the sun is. But, since this is being recorded and for posterity and also for the grace and decorum of this event, it's necessary that we introduce. Over to Professor Pallam Raju.
Thank you, Professor Deshpande. It is indeed a great pleasure, privilege, and honor for me to introduce the speaker of today's Amrit Vyakhyaan, Shri A.S. Kiran Kumar. Shri A.S. Kiran Kumarji is currently Vikram Sarabhai Professor at ISRO, Bangalore, and member of the Space Commission, Government of India. And it's our pride that he's also the chair of our PRL Council of Management. During 2015 to 18, he has served as Secretary, Department of Space and Chairman ISRO. And he has steered the implementation of the applications-oriented Indian space program. And this facilitated rapid development of the country in many important spheres of Earth's observation, communication, navigation, meteorology, and space science, as well as development of indigenous launch vehicles. He has led in the design and development of more than 50 electro-optical imaging sensors flown on various spaceborne platforms, right from 1979 with Bhaskara. Further, his role and in the success of missions of Chandrayaan-1, MOM, the Mars Orbiter mission, has been extremely significant. Shri Kiran Kumarji has been the chair of the Committee on the Earth's Observation Satellites. He has made valuable contribution to the coordination group of the meteorological satellites, expert team on satellite systems, World Meteorological Organization, and Indo-US joint working groups on civil space cooperation. Shri Kiran Kumar is the past president of Aeronautical Society of India and fellow of Indian National Academy of Engineering, National Academy of Sciences, India, Indian Society of Remote Sensing, Institution of Electronics and Telecommunication Engineers, Indian Society of Systems for Science and Engineering, Indian Meteorological Society, and several others. He has been conferred with honoris causa and DSc by 18 Indian academic institutions. He has been bestowed with, conferred with various government awards of Padma Shri by President of India in 2014. Other notable awards include Rajyotsava and Sri Vishweshwaraya Senior Scientist Award by the Government of Karnataka. And he is a distinguished alumnus of IISc, and Gujarat Ratna Life for Innovation Award conferred by Gujarat Innovation Society in 2014, and Lifetime Achievement Award by the Andhra Pradesh Academy of Sciences, and several others. He has been conferred with the prestigious 2018 International von Karman Wing Award instituted by the Aerospace Historical Society, together with the graduate aerospace laboratories at the California Institute of Technology, and the Chevalier National de Legion d'Honneur. This is something like highest civilian honor given by the government of France. This was bestowed on him in 2019. Again, as was said by my colleague, it is something like showing torch to the sun. So it's again, I can go on with many more accolades and accomplishments that Shri Kiran Kumarji has had, and not only that he led several programs in the country, and is now also showing direction as a member of the Space Commission to the Government of India. So with these brief words, I will now please request Shri Kiran Kumar to please come and talk about this today's talk, Vikram, Sarabhai, and the Indian Space Program.
Good afternoon, and I should thank PRL for providing me an opportunity to be part of this unique Amrut Vyakhyaan series, where it is the 75th episode, and it's always a pleasure for me to be back in Ahmedabad and also in PRL. Looking at, I've spent almost 40 years in this place, so it's almost like a homecoming for me. So thank you for this opportunity to come here and talk about this. And actually, if you look at the way things happened, Dr. Vikram Sarabhai and India's space program are actually probably synonymous in many ways. And while looking at the preparation for this, I had an opportunity to look at a book which came out as Science and Policy in India, which has been brought out, and where few of the talks what Dr. Sarabhai has given, if you look at how very different a personality he was, and how his thought processes are still so much valid even today, and probably we'll touch upon some of those things during the course of this talk. So what I intend to do is, of course, take you quickly through a set of development that has happened in the space program, and then get back to the way he had envisaged, and how not only he steered while he was there, and how it was possible for others who followed him to essentially remain within the ambit of what he had envisioned. And then, of course, this, all of you would have seen this, we must be second to none in the application of advanced technologies to the real problems of man and society. And to assure its development, India views science and space technology as a crucial apparatus for its socio-economic development. And Indian space program is very different and is very deeply rooted to society. We'll see many of these thought processes coming out of his talk in the subsequent slides. So the way I planned it is, first about 30-40 slides is quickly take you through how India started the space program and where we are today, and then get back to the actual Dr. Sarabhai, his thoughts, and the way he guided the whole thing. See, we are all quite familiar, way back in 57, the first object went into space, and like we see today, disruptive technologies, at that time, it was a very disruptive technology, giving human beings an ability to go beyond Earth, and then look at from space. Today we are all quite familiar that from space to Earth and space to space is all happening. But you need to remember, in 57, India was a fledgling democracy which had got its independence just 10 years earlier, and at that time, if somebody were to convince the government that we need to spend some of our resources on an activity of going to space and then make a dent in the country's development, probably it required tremendous capability for an individual to not only convince the power that be, but also demonstrate how this can be done. So starting with the first rocket being put in November of 1963, the activity started with practically no infrastructure in the country. Today, you have a self-reliant space infrastructure. So how it happened, of course, if you look at, he was able to convince his friends across the globe that we have a unique place in the country at Tumba, a geomagnetic equator. If you conduct upper atmospheric research at this place, it will be beneficial for the entire scientific community. And for doing that, not only his friends, but also through UN, he was able to get the sounding rocket in the form of kits, got it assembled in the church, what you are seeing in this slide in the left-hand side middle, and then with very limited actually resources that were available, start this whole activity of bringing in the act of going to space. And at that time, if you look at, India was looking at how do we actually reach out and provide communication to the entire country. And the first of the experiment, satellite instructional television experiment, which was planned, which actually took place between 75 and 76, was actually the result of years of efforts of Dr. Sarabhai, not only in convincing the Americans that they should provide their most advanced technology satellite, what is called as ATSF, allowing us to borrow it, bring it over the Indian longitude, and using that in Ahmedabad, build a capability of something very similar to what you are all familiar today of direct-to-home television, where a small set-top box and an antenna on rooftop is able to give you on your screen, TV screens, images. You imagine in the mid-70s, India was doing this experiment, the world's largest socio-technological experiment, and demonstrating to the country where in about 2,400 remote villages of our country, where at that time even getting power would have been a difficult thing, and developing almost half a rack worth of equipment direct community television sets, and using that, providing information to about 2,400 remote villages and more than 2 lakh people there, teachers and various institutions were brought together. And this act of demonstrating to the government, probably many of you would be feeling that if you are able to convince a politician what he is speaking can be heard across the country during 1975, you don't require much more convincing for them to approve the programs. Today the world is very different, but at that time, when what you are speaking probably could be heard only through microphones or speakerphones to a limited audience, this was a great demonstration. And the real benefit of this was the country, nobody in the world had done such a large experiment, though people were aware that from satellites at geostationary orbits, 1/3 of the globe is actually available for line of sight communication. It was only the thought processes of Dr. Sarabhai which took up this task, convinced the people who are building the most advanced technology satellites and making them aware that this could be done. Can you play this video? Can you play this video? Of course, this is just to take you back to a small video of the site broadcast.
Particularly in a country like India, where the large mass of people who have to be motivated.
Site, after an intense preparation of 5 years, began in 1975 for a period of 1 year. The television programs produced for this experiment were broadcast for the first time directly from a satellite to 2,400 villages of 6 states of India.
States which had the highest number of backward districts were selected. And then from within the state also, the most backward districts we tried to select. And that is how we identified 6 states and 4 districts in each state. So about 24 districts, and each district would have about 400 TV sets, so that we will have a total of 2,400 TV sets.
साइट टीचर्स कभी टीवी देखा ही नहीं था, उनको सिखाना पड़ा कि टीवी चालू कैसा करना.
With help from the municipal corporation, which gave us an old disused part of a municipal school, we converted that into a small studio, very small studio in Mumbai.
These programs were watched and appreciated by an audience who had no access to mass media.
Villagers' response was very good. Few villagers complained to us that these children have been taught so much in the village about hygiene that now it has become difficult for us to sit at home, because they say wash your hands before take your food, cover the food, don't leave it open, flies will come, sleep with mosquito net.
It showed to the country and it showed to the government that satellites can work and that they can be used to carry information to the whole country. Immediately after site, the whole national network was set up and the redistribution system was set up. More than 300 terrestrial transmitters were set up by the government within a year, and a complete national network came up.
So that was one in terms of reaching out information to the entire country. See, if at that time the alternate of providing information were to be followed, program got approved, and then the whole thing, we'll see subsequently how it developed. Another very important aspect was in terms of the ability to look at weather and weather monitoring. And again, though ATSF had a weather monitoring system, but it did not work and we were not able to do much there. But then subsequently the INSAT series has provided ability to look at the Indian subcontinent, and today you have an opportunity to look at what is happening on India and its surroundings every 15 minutes and through a host of activities. In fact, this particular this is actually recently we launched our OceanSat where you have a scatterometer, and this scatterometer provides you ocean wind vectors, and you can see the cyclone formation and how the cyclone changes. Today, a number of microwave sensors that are available provides information about the ocean parameters and also atmospheric parameters, not only to our own country, but also to the numerical weather forecasting community across the globe. And we are also actually participants in this. And today, with the kind of satellite-based observation capability that is there, India is able to deal with cyclones in such a very effective manner that in the earlier decades, super cyclone used to result in loss of life, more than tens of thousands of people. Today, you are quite familiar that in all the recent super cyclone time, NDRF or the National Disaster Relief Agencies get information very much in advance, so they are able to evacuate the people and save their lives. Another very interesting development that happened was Dr. Sarabhai had to convince the fishermen at Tumba that you need to vacate this place and allow us to conduct some experiments here, and if you do that, one day in future the country will benefit. For this, he also had to use the services of Bishop and to convincing the fishermen. And just as though to demonstrate what he had told, today what we have is a capability of looking at the color of the ocean through the satellites today in almost 13 different wavelengths, and looking at the color, identify the chlorophyll, and through the chlorophyll, the food chain of the fish, and tell exactly where in the ocean, if you go, the fishermen can catch the fish. And from 1999 onwards, Indian National Center for Ocean Information System at Hyderabad was started providing this information to our almost 7,500 kilometer coastline and more than 1 million fishermen who depend on their livelihood. To this, what has got added is, you are also familiar, we have our Navik constellation, which enables us to identify our location physically. Today, a small gadget which is battery operated is fitted into the boat of the fisherman, and when he is in the ocean, a mobile in his hands, the mobile need not have any connectivity to the terrestrial tower, because you are quite familiar, few kilometers away from any tower, no mobile operates. But then this mobile communicates with the gadget in Bluetooth or Wi-Fi, and the Navik satellite tells the fisherman where he is, and an app in the mobiles in the hands of the fisherman shows in a video compass mode where he has to go for fishing. Not only that, in his mother tongue, it alerts him about any weather vagaries that could occur in the coming days, or even alerts him if he is approaching an international waters. You are also familiar and read quite often in papers, our neighboring countries capture our fishermen because they are getting into their international waters. So here is an example you can see where the most advanced technology of launch vehicles, satellite applications being used by a person who does not know reading or writing for his livelihood. And this alone, the act of providing information to the fishermen, saves to the country between 10 to 15,000 crores a year. This was estimated a couple of years back. Because now the petrol and diesel that the fisherman is spending is saved, and also the time is saved, and he is assured of the catch. In fact, just a couple of days back, if you see the papers, Tamil Nadu has now provided more than 5,000 gadgets to the fishermen. And here again, probably I'll touch upon this topic a little later. While science and technology provides you solutions and gives you opportunity to make a change in the lives of the people, the vested interests do not allow that to actually come. The High Court of Tamil Nadu had to force the government to provide this capability to the fishermen. Otherwise, there were vested interests preventing the rollout of these capabilities and the fishermen making use of it. So this is an example where what Dr. Sarabhai had promised the fishermen actually plays out, and today India is among few countries which has got this capability, and it's also able to make a difference to the lives of the people. And then in terms of communication capabilities, like starting from telling about the broadcasting information and also connectivity, after the site experiment, INSAT series was approved, and INSAT series, while the first generation, again what ISRO did was it came up with an idea which was very different from what existed till that time. A single satellite providing broadcasting, communication and meteorology all three in one, and that kind of a satellite was quite complex, and first generation was realized by an American company as per the ISRO's requirement. But then INSAT 2 onwards, all the developments in the satellites is happening indigenously, and today you have a host of satellites providing communication capability, including broadband capability and multi-beam, and very soon is also going to increase, provide to all the gram panchayats in the country almost like 20 megabits capability. So these significantly the progress is happening, and development of all these technologies happening indigenously. Another very important development was in terms of navigation, and then initially Indian subcontinent was a whole in the global you can say aircraft navigation, and this was filled by providing Gagan instruments on our satellites, and later we came up with a Navig constellation, which is a 7 satellite constellation. Unlike what Americans, Russians, Chinese and the Europeans did of a constellation of 24 to 32 satellites, India went for a, you can say, frugal 7 satellite constellation, but the penalty was we are providing this service to India and surrounding India up to 1500 kilometers, and today this Navig is providing services for railways and also in terms of fishermen you have already seen, and many of the newer mobiles are being equipped with Navig enabled services, and something similar to Google type of service is also being contemplated by companies like MapMyIndia, etc. And then for making observation of Earth from space, India had to build a host of imaging and observations instruments, starting with 1979 when Russians offered the couple of satellites to be launched. Using those satellites as platforms, we learned the art and tricks of providing Earth observation information and gradually building capability. And today you have imaging instruments which provide you sub-meter resolution in optical, microwave, the wavelengths, and also ability to look at Earth from geostationary platforms and low Earth orbiting different platforms. It's available. Similarly, in terms of meteorological satellites, again starting from INSAT series, today we have INSAT 3DR and Sounder, which allows every 15 minutes observation of India and its surroundings in various wavelengths, optical, infrared, and also in terms of shortwave infrared, and this data is provided to the Indian weather community, and also using microwave sensors, where many times you may wonder between June to September India is covered with clouds. So what can we see from space? In optical and infrared you can only see clouds, but like we can see through the glass is transparent to us. In microwave, cloud is transparent to microwave, and building microwave sensors, today we have scatterometers which provide us ocean wind vectors, and you saw one of the examples of how today's ability to actually predict and then match patterns and identify the cyclones, etc. happens. And then in terms of observation of hyperspectral instrument, instead of looking at few wavelengths like your mobile is able to provide you RGB, whereas if you are able to see in large number of wavelengths, you can study lot more about the various aspects, and we have this hyperspectral imaging capability. And microwave, like I said, because it operates with its own source of information or source of illumination, so it can operate day and night, and we have got various wavelengths, Ku band, C band, X band, and all these data operating in inclined orbits and different constellation is providing data. All these data from different wavelengths, optical, multispectral, multitemporal, provided with a digital elevation model, again generated from our own digital elevation model stereo camera systems, and navigation enabled positioning information, and a set of models and a suite of application. Today, socio-economic security, sustainable development, disaster risk reduction, and governance, in all these areas activities are happening. one of the things Dr. Sarabhai had mentioned earlier was how when you bring in a solution, you need to make sure that those who are using the solution are needed to be convinced of the application. And this is one area where actually the problems are not simple. Probably many of you who have attempted to sell some concept to a person, if you go to somebody and tell him what he is doing can be done very differently with a new technology, the first response you will get is, I know my job better, who are you to tell me? So when the space technology came in and the idea of providing space-based information, we had to take it to the different departments. There were early adopters of this, and there were late adopters, and there were laggards. So Forest Survey of India started way back in 87, and India Meteorology Department, while it accepted the space segment from INSAT series, its actual utilization of data it was doing on its own, because it was using the actual processing systems from a Canadian company. But then later they realized that it's a fallacy, and they started using it more effectively. And Airports Authority of India, you see in different time scale, and even the Mahalanobis Crop Forecasting Center started establishing its own center in Delhi for identifying that crops that you can identify and tell ahead of harvesting what is a crop yield. And then this is another very significant example. It's only when the person who is actually governing understand the advantages of technology and then makes effective use, things change. We all know our Honorable Prime Minister, while he was in Ahmedabad, he had made extensive use of both communication and remote sensing with the geospatial technology cell here that BISAG, Bhaskaracharya Institute of Space and Geospatial Technology, and he had made extensive use of space-based inputs in both governance and other activities. And when he took over in 2015, we conducted a great, almost a 2-day program where all the secretaries of the various central and state governments were brought together, and each of the departments, what the space technology inputs can do in the department for enabling them to not only monitor but plan and evaluate. And this activity actually gave a significant fillip to the use of space technology in the country. While all this capability of building observation and then actually reconnaissance or microwave data communication, broadcasting, navigation, India also was doing space science experiments as part of its space program activity. Here the key thing is that we all are familiar that if you need to be contemporary, you need to be solving problems of the latest level of difficulties, and then if you want to use space for observing space, then you need to build instruments which can make use of very little resources and then make it miniaturized. And right from the Aryabhatta time, every opportunity that was available, ISRO was making use of it in building instruments and looking at what can be done in space science. And then for this you had to go through different orbits, from the low Earth orbit to geostationary orbit, and then to Moon and to Mars. And in all this, many innovations and then trying to make use of the technology access you had were attempted, and the successes that were achieved also you're all quite familiar with that. And then what the space science program itself did, while Chandrayaan-1 was a vehicle which actually went to Moon much later than man landing on it and a large number of probes going around it, but still the credit for discovering the presence of water and water molecules on Moon goes to Chandrayaan-1. Similarly, Mars mission, when it was done, it was the first mission, we were the first country to achieve in its maiden attempt. And with a launch vehicle, which was the Polar Satellite Launch Vehicle, this was achieved. And last year, towards April, after 8.5 years of successful operation, the Mars mission ended. And using this data from space, you can do a host of activities, whether it is for wind, solar, and wave energy, and all this, and also in terms of climate observations, data is collected. And while India built all these capabilities, the scenario changes, and India is today among the 5th largest economy in the world. And if you have to remain contemporary, you cannot be remaining isolated in your ability to go out into space and use space for many other activities. And India started its human space flight program with the objective of, before the 75th year of Indian independence, few of the Gagannauts were to go into space and come back. But COVID ensured the availability of resources and delay in program. But today, this activity is going in full stream, and you will see in a couple of years Indian Gaganauts going into space and coming back. So this in a nutshell today is where we stand. While the space economy itself, if you look at what is talked about, is space economy is going to be a $1 trillion economy, and India is among the few countries in the world which has an end-to-end capability of building launch vehicles, its own cryogenic engines, building satellites and application, and a large number of international programs it has done. But the world over, things have changed, and space is no longer just the, you can say, operating space of nation states. Private enterprise is moving into this. Space is considered as the 4th frontier, where space tourism, space adventure, space exploitation, space exploration, they are all becoming significant portion of the human endeavor to conquer the 4th frontier. And should India be left behind in this process, can only the government continue to fund and operate in space? That is where India has made a change, and now it is trying to enable its countrymen to be a significant player in the space economy and reach from maybe about 2% of the space economy today, which is in the $300 to $400 billion, and reaching to $1 trillion by that time. If we have to achieve 10 to 20% of that economy, then a large number of people have to operate, and that's what the government is trying to do in making these changes. Coming back to the basic issue of Dr. Sarabhai and the Indian space program. See, Sarabhai's vision for enabling India was to leapfrog into the future through the adoption of appropriate technologies, early adoption of new technologies, innovative use of accessible technologies for addressing societal problems. You can see in sight, the experiment was, while people had built satellites, taken it to geostationary orbits, the first largest socio-technological experiment of demonstrating how a developing country can use such a capability to reach information to its entire country was done in sight. And then India, by virtue of adopting the technologies between 95 and 99, became the provider of highest resolution imaging in civilian domain. Similarly, if you look at Mars orbiter, it became the innovative use of its capabilities to reach out to other planet. And then in AstroSat, India has today the world's highest angular resolution telescope operating in ultraviolet, and because of this, Indian research community is able to get information ahead of others, virgin data to the Indian researchers, and this is the first observatory operating in space, and also 104 satellites in a single launch when it was done by India. It was again a very significant development, which shows that while you have access to technologies which are available, you can actually look at the whole thing very differently. Now, leapfrogging as a concept, if you were to look at what it means, is actually, if you are actually a high jumper, what you have enough space to run and build momentum. But if you do not have that kind of a freedom, and if you have to do a jump like what a frog does, it conserves all its energy and then jumps. So in many ways, you can see that what you can call as leapfrogging as a technique is what Dr. Sarabhai had been proposing, and that's what was adopted by Indian space program in using all the technology that is accessible to it. Whatever technology that is not accessible, build it indigenously and then move ahead. So it conceived of solutions to the problems we were facing in the country, whether it is the fisherman's problem, weather problem, or in terms of today, the application has gone to a wide range of activities. Now I'll come back to a few of the things what Dr. Sarabhai had been actually telling. I'll read out from a couple of his papers what he had done. This was a 1966 paper where he is trying to justify space activity for developing countries. In that he starts with navigation of Mariner 4 spacecraft to successfully accomplish a flyby mission to Mars, and the telemetry of television pictures from a distance of 13.5 million miles are milestones in technological and scientific progress. While applauding the magnificence of this accomplishment that these represent, we should also appreciate the understanding displayed by the organizers of this mission, because they were worrying about not polluting the life on Mars. So he says, at first sight, it might appear odd that a developing nation such as India, where the annual per capita income is about $80 at current prices, where the average expectancy of life is 45 years, this is in 1966, and the population grows by about 13 million each year, should think of things other than the immediate problems of population control and of providing food, clothing, housing, etc. Now, what is the value of space research in such a country? People seriously ask this question, both at home and in foreign lands, and yet we have a model space program with which I have been actually connected from its inception some 4 years ago. I therefore feel it appropriate to share my thinking with you. Some of the comments which I have made are perhaps applicable to all developing countries. Others are of special significance to India. I will deal here first with the close relationship between understanding science and the ability of a nation to develop through the application of science and technology. Secondly, I will deal with the role of international cooperation in an advanced field such as space research in the transfer of know-how and technology and creation of an overall climate, visually vitally necessary for a developing nation. Thirdly, I will discuss the significance of collaboration between advanced nations jointly undertaking assistance to a developing nation. Clearly, the development of a nation is intimately linked with the understanding and application of science and technology by its people. It has sometimes been argued that the application of technology by itself can contribute to growth. This is certainly true as an abstract proposition, but fails in practice. Witness the state of development and social structure of countries of the Middle East, where for decades oil resources have been exploited with the most sophisticated technology. History has demonstrated that the real social and economic fruits of technology go to those who apply them through understanding. Therefore, a significant number of citizens of every developing country must understand the ways of modern science and of technology that flows from it. An ability to question basic assumption in any situation is fostered by probing the frontiers of science, whatever field one may be engaged in, whether it is biology, genetics, atomic science, or space research. It is the ability rather than empirical hit and miss approach which proves most effective in taking the day-to-day problems of the world. It follows from this that countries have to provide facilities for the nationals to the front rank research community while providing such an opportunity. The pursuit of cosmic rays and space research in a developing nation does not require an apology provided the activities are within the total scheme of problem priorities in the allocation of national resources. Many of us who are engaged in pure sciences are also involved in the organization and conduct of education, of planning, of individual development in fields such as electronics and chemicals. When a developing nation gets actively interested in a field such as space research, it inevitably establishes collaborative relationship with organizations as well as scientists and technologists in foreign lands. Through these relationships, it starts knocking outwards from its encapsulated existence born out of emergent nationalism. It learns to deal with peers, to establish a mutuality even when the flow of know-how and technology is largely in one direction to start with. International cooperation in science contributes to the creation of climate for development, which is essential in an age where colonialism has largely ended. When a nation succeeds in setting up a scheduled program, scientific program with sounding rockets, it develops the nucleus of a new culture where a large group of persons in diverse activities learn to work together for accomplishment of a single objective. In appreciating the value of space activities to a developing nation, one should recognize some inherent problems. They arise from the glamour that is associated with space activities. You can see the very thought processes here, what he has. There is a real danger that developing nations may adopt a space program largely for this glamour, devoting resources not through a recognition of the values of which we are talking about here, but from a desire to create a sham image nationally and internationally. International cooperation in space activities may stimulate the state of affairs. There is an easy way to prevent such perversion. However, the following factors may prevent this from happening. One should ensure the nationals of the country at the appropriate level, at the operative level of the program, are efficiently committed and effectively committed and are willing to stretch themselves to the fullest before adopting or asking for help from outside. And then here he is trying to showcase that the way you are approaching this problem, actually many developing countries, when they are approaching the so-called developed countries and providing solutions, they can be actually misled and misdirected. And this problem you see all the time, that when you are developing a new capability, you are recognized for what you have demonstrated capability and not what you have claimed. And that's where, in fact, even in our own development, both Chandrayaan mission and the RadarSat mission is the one which resulted in India working with Americans for a $1 billion program, where today we are working together. They spent $0.9 billion, we spent $0.1 billion, but the most advanced technology of radar imaging, which will provide minute details to the extent of few millimeter change on the surface of the earth, which can be generated at quite frequent intervals, they are working together. And such a thing happened only after the successful mission of Chandrayaan and actually RadarSat missions. And then similarly, if you look at another very interesting book, paper, where he talks about peaceful uses of outer space. India has established at Tumba, with the active cooperation of the United States, Soviet Union and France, an equatorial sounding rocket range. This international facility has received United Nations sponsorship and is a unique example of nations following different political paths joining resources for promoting the peaceful uses of outer space. Modest as the experiment is, I believe it provides a model of great significance to the future. So too is the experimental satellite communication earth station at Ahmedabad, which has received support from the United Nations Development Fund and the International Telecommunication Union, and now runs an international training center. I believe that several uses of outer space can be of immense benefit to the developing nations wishing to advance economically and socially. Indeed, without them, it is difficult to see how one can hold their own in a shrinking world. I shall try to outline today some of the objectives of space research and some implications of the practical uses of outer space. There is a very interesting example which he gives here. Of course, it talks about what should be the space research itself contain. The sun provides the driving force for almost everything that happens on Earth, weather, rivers, vegetation, fossil fuel, and of course life itself. But in contrast to apparent constancy of the sun and the complete dependability of sunrise and sunset, we experience a capriciously variable environment. The fury of hurricanes, the lashing of the ocean waves, droughts and floods, starvation one year and bumper crop another year, and uncertain radio communication, the natural scientist looking for the subtle links through which the sun, how sun affects Earth and our lives has acquired in the exploration of space a dramatic new capability for study. It's discovered that in the solar system, the space separating the sun and the planets is filled with extremely rarefied matter constantly flowing outwards from the sun with a velocity of about 300 to 500 kilometers per second. The solar wind, as it is called, carries with it the sun's magnetic field, and regions around planets is broadly analogous to what happens when a big boulder sticks out in the middle of swiftly flowing stream of water. Now he is trying to showcase to a layman how space research and the ability to go to space and make observations makes a difference. There is another major interest in exploring space. The Earth's crust and the lower atmosphere have such temperatures and densities of electromagnetic and hydrodynamic phenomena functions largely independently of each other. But this state of rather special and does not commonly occur in the universe. Third important scientific objective is to keep view of the universe and the galaxy and the solar system through a wide window. And then he goes on to talk about how the blanket or the atmosphere around Earth is preventing you from making observation of space, and then how when you go beyond the Earth, your abilities become very different. Then technological advances which have provided weightlessness and permitted man to free himself from the solid Earth has opened up a vast new field of human knowledge. So in such a way that he goes on in this particular article also to actually convince people that space provides a unique ability, and with these arguments he was able to convince the powers that be. Now I'll just run through a few of the quotes from him. See, for example, in this he says, "Those who can apply their insights to the problems of the community and the nation discover an exciting area of activity where effort is rewarding even while the results come slowly." Then here is again a very, I would say, a very significant statement the important ingredient for satisfactorily meeting the challenge of the changing environment is not experience, but the ability to learn. This is where many times we actually, in managing things, misread the whole situation, trying to give experience too much of an importance, whereas what is required to understand and then to move ahead is not so much as an experience, but the ability to learn and use that learning in adapting. And in finding those solutions, you may make use of experience, but the primary objective first is it should be your ability to learn. Experience is less relevant than knowledge and the ability to learn and innovate. And today, in the current context of rapidly changing information base, we all know that learning, unlearning and relearning is all very important. And then this is one very interesting quote. You can see here when Dr. Sarabhai was asked to hire some people for Atira, advertisement he had put, candidates with previous experience need not apply. Then technology is not an objective to be aimed at, but a tool to be used for the benefit of the common man. And in fact, it is this particular aspect which in a way you can say ISRO continued to make sure it used, because it was, while indigenous capability is an important aspect, if something is accessible to you, don't be so much obsessed. If it is accessible, pick it up, and then what is not accessible, that only you create here. And this is an important difference in the approach. In implementing change, we need to apply ourselves to people before we can apply to problems. This is another very important aspect which many of us ignore or find problems to our own peril, the unsuccessful implementation. The people who are doing things should be given the due importance, is what he actually kept telling. And in his own way, he used to create groups of people who would work on similar problems simultaneously, and then once a suitable person who is doing the job is found, given all the necessary support. There are some, of course this is very clear, there are some who question the relevance of space activities in a developing nation. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with economically advanced nations in the exploration of moon, planets, etc., etc. But of course, many of you might feel, are we still following this? But then, as he himself would have said, you have to adapt yourself to the changes. Today is India no longer a developing or a country which is just trying to feed its millions problem, but it's among the 5 economically strong countries, and very soon it is aiming to become one of the top countries. And then the geopolitical situations around you and the kind of international recognition that you get depends on what you have demonstrated. So you need to change. But then for a long time, this particular approach was essential. This is another very interesting statement. Trust cannot be taken for granted. It has to be continuously created and built up. This is another problem which many of us face. Maybe once we think, once we have done something successfully, it has given us the trust for rest of our life. But that is not true. You have to keep continuously building it up and ensuring that that trust can be one can be trusted. It is good to recognize how to relate oneself to other specialities without going through a sense of failure. This is an outlook difficult to attain, but is nevertheless essential before one can reach one's goal. In fact, in some of his talks, he has made it very clear how the developing nations were looking at condescendingly on the developed nations, and when they are providing solutions to them, how up to some point of time they will take it or dissuade you from doing your developments or going ahead. But then when you are looking at something new, some new activity, you need not be actually feeling limited. That's what is actually meant. And then you can aim and this is particularly valid in today's scenario where the changing situation is probably bringing India back to, in some ways, another colonization which is happening. Now, it is really behavior of people, of institutions, by which real working culture of the company develops. In nature, left to itself, control is maintained through an ecological balance. Order is not imposed from above, but arises through the interaction of each unit with its environment in a dynamic equilibrium. In fact, many of these quotes are taken from the book, where the author of whom is sitting here on the front row, and he had picked up many of these things and brought out in a nice book, and I have simply picked them up for showcasing. And just 2 or 3 other points before I close. In fact, many of the things what Dr. Sarabhai had envisioned and then had told that should be done. In fact, even today, we have not completed the task fully. So whatever the targets he had set at that time, whether if you are looking at shipping, the type of information that is to be done, wave height, surface temperature gradients, color of water, etc. These are the parameters that can be done using space, and many of these things, whether it's in meteorology, coastal geography, marine biology, seafood, in all of these areas, actually he had pointed out that these are the capabilities that one can develop using space program, and a large number of them today are in operation, and the very recent launch of OceanSat also carried many of these capabilities. Similarly, while explaining the uses of telecommunication, he had put at one place who all could be the beneficiary of that. The use of in All India Radio, Post and Telegraph, Defence, Ministry of Home Affairs, all these were the possible users of the technology that was going to be made available at that time. In fact, this is another very interesting thing which is valid even today. I would like to narrate. In one of his talks, he talks about how information actually grows and can have impact. So he says, if each of you give, it could be simply a rumor also, anything, you talk to 3 others and then tell them, and each of them tell to 3 others. This he is talking in 1966 to explain how rapidly exponential growth changes. At that time, India's population was around 390 million. So in 18 steps, you would reach 390 million. And then if each step takes about 1 hour, then in 18 hours, all the people would have been covered. But still, in the last 2 hours only, 90% of the people become aware of what is going on. Now you fast forward, you come to today. You have in your hands a device through which you can communicate with a large number of people, and in a less than a second this cycle can change. So now you can say, instead of 18 steps, if we are talking about 8 billion or 7 billion global population, 18 steps may become 25 steps or something like that, or 20 steps. But then the time in which it happens is so short, and then the impact is also going to be very different. So he was able to bring in such excellent examples and convince people who mattered that how things are changing, how our ability to communicate with people during whether it's broadcasting, communication, etc. He had used such things. And again, all of us are quite familiar what happened during Corona times, and then how people were talking about the models, how fast it grows, etc. So this particular aspect is a very interesting thing, where he was capable of not only visualizing, but also putting it across very effectively. In a way, you can say he demonstrated in his life his conviction that the end of all scientific endeavor was peace, prosperity, and creativity. His vision of human society complemented his concept of holistic science. He used the tools of physical sciences but spoke the language of social sciences. Every activity he chose to initiate and every institution he created was of profound significance for a developing society. Into every one of his endeavors, he breathed the rigor of a dedicated scientist and the sensitivity of a humanist that his laboratory enveloped the entire community was amply demonstrated in his pioneering the management movement and applied industrial research. A positive approach out of our predicament lies in finding solutions where the particular disadvantage of developing nations, which is that they have little to build on, is made an asset rather than a liability. It is necessary for them to develop competence in the advanced technologies and to develop them for the solutions of their own particular problems, not for prestige, but based on sound technical and economic evaluation involving commitment of real resources. Finally, Sarabhai's vision on the development of space technology and its extensive application for the betterment of society continues to be the guiding light of our space program even today. Okay, thank you very much for this. Some questions?
Some questions.
Yeah.
You can sit here.
Okay.
Thank you very much, sir, for this very extensive platform of Vikram Sarabhai, the Indian space program, and how the things have evolved. And I must especially thank on behalf of everyone that you have done so much of research, you have gone into the literature and their actual write-ups, because normally we get to know from Google or some other sources, but you have actually gone into the details. So we are really thankful for your kind efforts. Now we'll have a question answer session. I'm sure there'll be many questions from this broad spectrum. I'll invite Professor Lokesh Sahu, the co-chair of the Vyakhyaan committee. And I would also like to tell all of you that there would be questions, because this is being relayed live, so there would be questions on YouTube, and Dr. Durga Prasad will let us know what those questions are there. He's sitting there and he'll let us know. So floor is open for interactions. Thank you, sir.
First of all, thank you, sir, for being the important part of this 75th Vyakhyaan. And after Vyakhyaan, the interaction session or question session has been the key part of each Vyakhyaan. And I must thank all our audiences. Earlier they used to join using WebEx and YouTube for their enthusiastic and active participation. So now for today's Vyakhyaan, the forum is open for the question and answer or discussion sessions. So I invite you all to raise your hands and interact with Shri Kiran Kumarji. So for this, I also request my colleague Manas and Vinit to assist me in moving the mic. Please come. And I request, yes, the forum is yours now. Please. Yeah, there.
Yeah, thank you, sir, for a very nice talk. Being a student of physics and an academic faculty at PRL, it is hard to miss that during the formative year of Indian space program and much later, the ISRO and the space program was headed by physicists, and if I have to include Professor Satish Dhawan as well, by the academicians. For last 2 decades, we see that there's a change in this approach, and physicists are kind of missing in the, the leadership role. So,
I'm a physicist.
Yeah, I mean, I was about to say a possible exception. So
Kasturi Rangan was physicist, Professor Rao was
physicist. Till Professor Kasturi Rangan.
Okay.
So what should we infer from that? Is there a message in this for us? And how did it affect the vision and approach of ISRO? And how it would affect the relation between ISRO and the DOS system with the academic community in general?
Okay, I think probably what we really need to look at is beyond who is leading or what is leading. If you look at the way the organization has developed, the prime objective has always been how to make use of space technology for the development in the country. Now, when you are talking about use of space technology for developing in the country, now technology development per se requires a certain category of expertise. Then converting, visualizing what is that technology to be used for, what kind of problems it has to be used for, what kind of solutions have to emerge, that is where there is a difference that comes. So it always has to be, you can say, a mixture or combination of both those who can look at technology development and those who can look at how the technology can be used for addressing the problems of the society. So while this kind of a thing between the technology and academic approaches keep going back and forth, it's quite natural that sometimes one group will be there and it changes. This is a natural process that happens. I don't think we need to pay too much attention to that, because if you look at all along, the emphasis has been how can we use the space technology for the harnessing it for societal use. But what is changing today is more than what is happening within ISRO, what is happening outside. That is what you have to see. If you look at India over a period of 4 to 5 decades, it has brought from scratch an ability to reach to space, put objects in space, and then provide you capability to do communication, broadcasting, meteorology, monitoring, space science, all that. And all this time, you are a developing country, and the nature of space technology itself, because it's a dual use, you have limited access to certain things, and you have to develop a lot of capabilities in that. And as a country, you do not have large resources, because again, if I were to tell you that till today, whatever India has spent on space program, including adjusting for the value of money, does not add up to more than a fraction of 1 year's budget of whatever advanced countries. So with that kind of a resource, if you have to develop capability and then provide solutions, there is a limitation to where you can reach. So you have reached where you are, but where has the world gone? See, like I was telling, the space is no longer the preserve of nation states. Today, human beings are entering into conquering fourth frontier. You have private enterprises doing space activities outside the governments. And if India, among the few countries which has this technological capability, should it still remain like that, or should allow itself to grow into a situation where you can also be a significant player in space economy? If that has to happen, the government has limited resources. Already, once you solve the problem of cryo engines and then you are trying to push amount of money needed for in India, today you have probably 50 odd satellites operating. You look at any contemporary similar capable countries, you need maybe in the range of 200 satellites operating. So how to build the capability? This capability, if it has to be built, there has to be more funding, more capacity, and the capacity can come only if you put in more money. Government has its limit, so it is trying to make the private enterprise move ahead and be competitors, and it's trying to make. So more than what is happening within the organization of ISRO, India as a whole should look at how this technology of space can be used not only for providing the essential requirement, but also to survive as a country among the equals in the top. So that is a real challenge.
Thank you, sir. So
yeah, something here.
Yeah, yeah.
Yeah, thank you, sir, for a very excellent overview. See, until quite recently, the mandate was societal impact, which Sarabhai pushed. But now we are branching off into fundamental research, science with Astrosat, Aditya and things. I just wanted to know, is there, I mean, while the other part, the earlier part is easy to sell to the politicians, because societal impact, they gain directly from it, Have you found any resistance from the government to, carrying out fundamental research on the same scale as the earlier period?
No, I think even in the earlier times also, see what ISRO has been doing is, see while the basic tenet was harnessing space technology for societal use, but in harnessing technology, the basic approach was what is accessible to you use, what is not accessible you develop. You build capability. Now when you have to build capability, you have to actually pose challenging problems to yourself and keep solving those challenging problems. In the process, improve your own capability to deal with the whatever societal applications that were there. See, in that context, from space science, even the very first mission also, Aryabhatta also had a number of these things. So to that extent, the science, and then in doing that science, whatever technology is needed, using that was going on all along. And our own Chandrayaan and Mars missions, etc., if you look at, it's an essential component, because in space, when you want to be in space, you need to have systems which can operate with less power, less energy, and more efficient, more intelligent. All that capability you have to build. That's one part. Now coming to your other primary question, that which is easier to sell to the government? That is, in a way, the question what you are asking is that. See, when you are in a scenario where the country is going through a phase where it is emerging from independence and building its own capability, till you reach a certain level, the way you are looked at by the external world or other people is different. And also you had a lot of limitations, constraints. But then this land being what it is and capability being what it is reaching a stage where it is going beyond all those limitations. And once you are going beyond all those limitations, the need for the country is, like I was talking about, it is capacity today, not capability. Capability has been demonstrated. But to translate capability to capacity, you need more funding from the government. Governments always have problems. They have hundreds of other things to worry about, and then those who are asking for more and more, they will try to find ways, what alternate way it can be done. So today, if you really look at, like I said, India wants to reach the higher echelons of economic activity. If space economy is $1 trillion, and should you not get, being one of the few countries with this capability, to reach at least 10 to 20% of that economy? If that has to happen, what needs to be done? So the changes that are taking place are that. Because by the time we solved many of the problems and reached the current stage, we have done this in the available conditions with the available resources. Like I mentioned, whatever resource was available also was limited. All the time you had to balance between your R&D. For example, semi-cryo is an essential requirement. Reusable launch vehicle is an essential requirement for bringing down the cost. But did you have enough resources for doing those experiments? Experiments have been conceived. They have started, but you do not have actually resources for doing effective things. That means you have faced with a problem of resources. Now the government is trying to tell, as a country deal with it. Let more and more entrepreneurs capacity be dealt with by funding from private enterprise. Let them do all those activities which can commercially be viable. So that's how things are moving. So it's a problem. There are no easy solution. Every one of us have to change. The way ISRO operated also needs to change, because now it has to deal with in a different way the entire thing. But I think the problem is understood by everybody. Solutions, implementation is going on, but then it's not an easy scenario. There are no clear-cut paths for this. So everybody has to do their best to the best of their ability, and a few years down the line, we should be among 20% to 25% of space economy. And you have seen already the results. Our LVM-3, for example, if you look at a vehicle which had not performed a task of putting more than one satellite at one place, was tasked to put 36 satellites by doing lot of changes in the mission. And a private company accepting such a launch from a space thing, an untried or unattempted system being used for launch, there are a lot of risks for everybody. But then the country went ahead. Today, the company is going, as another thing will happen in shortly a month or so, and a lot more will happen through NSIL, getting more and more offers for launch vehicles. So the things are moving ahead, but in this flux, everybody has their own view of what is happening. So until the things stabilizes, there will be ambiguity. But direction, nobody has any doubt, and everybody knows they have to find their best, they have to put their best foot forward for India to move ahead.
Thank you, sir.
Thank you, sir, for elucidating that.
Yeah, Professor Shri.
Here.
Yeah. First, a comment on the later side. When Professor U.R. Rao and Dr. Kastur Rangan, when they took over the reins, they were already converted into hardcore technologists. Just as all of you are trying to convert him into a physicist. Okay, the question to you, sir. The thing is, the government has been very keen in encouraging all other departments to use the space assets, whatever we have created, and the information that we are getting it. And you were, in fact, heading the group of people. Has there been any improvement in the utilization of it since that step that was taken, which was very, very essential?
Yeah, I can definitely tell you there has been a very significant improvement from what was happening earlier to this, because in that particular program, the person at the top spoke extempore for 45 minutes, telling all the secretaries how in their department information from space can be used thing. Of course, what we also need to appreciate is ours is a huge country with complex problems. But then if consistently the people at the top keep demanding, things change, and that's what's happening. Maybe I can give you one more example of how things happen, though of course this is going globally, but still it's worth telling. Using the space-based information for monitoring projects which are going on for decades, he started monitoring, conducting every month one discussion where all the people who are running that project were given opportunity to tell on why the status of that project is where it is. So initial times, the people were probably thinking that they can do whatever they have been doing, and then they gave some explanations, and then on an alternate screen, the actual scenario based on in situ observations made from the program was shown to them, and very soon they realized that it is no longer possible for you to tell what you want to tell and get away. So because monitoring, space gives you that advantage. Space gives you an ability to look at beyond state boundaries, district boundaries, national boundaries, etc. So information is available, but again there is a problem, because we are all quite familiar that science and technology and information are neutral. The users of them are not neutral. Yes. Some want to prevent availability of that information, others use it but that is human nature, and we are all human beings, so we live in the real world. But today, this transparency, digitalization, and these techniques, etc., whatever is there, is showing more and more people who are making appropriate decisions are being forced to look at the information that is coming, and that kind of change is happening. And like MNCFC, for example, started today, now they are adopting much more. More than 68 departments have used projects, so it's increasing. But is it enough? Is it sufficient? That question is always a problem, because in India, no matter what you do, it looks like a drop in the ocean. So our both in terms of size and in terms of implementability, there is a question. But definitely what is happening today using space technology based inputs in both monitoring and implementing those monitoring things is much higher level than what it used to be.
Thank you.
There's one person there. Yeah, here.
In the center, yes.
Thank you, sir. Actually, my question is regarding the importance of fundamental science, like not exactly related, but since you already said that the Indian space program is actually not only going for societal applications, but also trying to be a world leader, since we are largely growing as an economy. So shouldn't we also try to be world leading in fundamental research also?
Yeah, what prevents us from becoming?
No, but the point, yeah, like you said, like I think I saw a trend that the percentage of the budget that has been allocated to fundamental science is reducing year by year in India.
No, here, of course, it's a simple discussion, not any. Definitely, today, if you look at science and what science has to do, fundamental science should always be there. Even if you see Dr. Sarabhai's these things also, you will find that. But what is the real problem? The real problem is if you can say that whatever fundamental science you are doing, for doing that fundamental science, the kind of tools and technology required for you, if that is a limitation, then you are always behind, because there are those who have made use of, developed those technological capabilities, and in some ways they are ahead. Now, if we have to make a difference, where is it possible? That if you see even India today also, if you see in what areas India has moved ahead, with the kind of access to technologies that were available, and where intellectual capability is all that was needed to provide solutions, in those areas you have moved ahead, and you have also provided solutions to the problems of the world in a manner which is very different. Though it might appear very different from what you are asking, I want to link two issues before I come back to what you are saying. The way India dealt with COVID situation and the way India dealt with in the digitalization, the whatever services that are there. In both these areas, India showed to the world that the solutions that needs to be adopted from the technology is very different. Now, even in COVID also, there are companies which have developed vaccines. They are all worried about their IP and the returns they get from that. Whereas India showed that it is the health and health of the people across the globe that is more important, and it's trying to fight. So the point what I was trying to tell is, if we go with the presumption that whatever so-called fundamental science today requires more and more technology-based support for us to continue in that, and we depend on others for that, then there is no way we can make a significant change. The only way we can make a significant change will be, can we visualize activities or areas where with this knowledge you are able to do something which is very different from what others are doing. You don't need that kind of tools, a different kind of tools, or use a tool which is available in one domain, adopt it in a very different way, and go ahead. If any of these things are possible, then you can do very differently. Otherwise, the problem of saying that science is not getting its due, or there is not enough support from the government. Government has its problem. There is nothing they can do, because if they want to see, for example, today they have already said in quantum technologies we want to spend 8,000 crores over many years. But then how it is going to actually play out depends on the people who are involved in that, how they work together, and then how they contribute to that. See, unless we are able to find ways and means by which the access, technology access we have, using that we can do things very different from the rest, nobody will allow us to move ahead. So the challenge for you is identifying such a thing and making it happen. In a limited way, ISRO did that and demonstrated that space technology, when it became available, how that technology, which was being used primarily for only military. India is again the only country which started space activity for applications other than military. But then today it cannot remain like that because of what is happening in your neighborhood and the way the world is changing, etc. But then all the technology that was accessible to you used, and then you showed that you can do things differently, whether your Mars mission or even 104 in one launch, etc., etc. So similarly, probably there are opportunities where the quantum technologies that are there, the thought processes, and then the tools that are required may be easily available for us developing. I don't have an answer to your question. It's just some free thoughts I have talked.
So thank you, sir. We can take next question from there.
Thank you, sir, for your enlightened talk. I just had one question, like to preserve the Sarabhai sir's vision, like betterment of society is the major part of any space mission or space related things. But being private parties, entities, and in the previous experience, we thought that there will be money will be the center point of the overall the things. So in that perspective, what will be the ISRO's or DOS vision, or the things should be done by the ISRO's do's and don'ts to preserve the Sarabhai's vision for our society, according to you, sir? Thank you.
Okay, I think in some ways you have discussed this, but I'll again repeat. See, today what you are looking at is, when you say private entities doing, etc., so obviously the private entities will do those activities which will be remunerative and beneficial, and where they are ready to put significant amount of money today if tomorrow they are expecting to get a good return. If you look at what Elon Musk has done, he earned from some other activity and he put in significant amount of money, and probably at the time of his 5th launch, if it had failed, maybe he would have shut down the shop. But then it went ahead, and now today he is talking about already whatever the providing internet service across the globe, and then converting humans into a multiplanetary species, etc., etc. So if you have deep pockets, you can withstand the vagaries of commercial thing and survive. So private entities will continue to do that. Their interest will be primarily using whatever technology access they have, using that, generating more and more resource, means more earnings for them, providing the service that is required. So that is their task. But then the governments have tasks other than that, where it has to make sure that it protects its citizens, and it also provides as a global community also, it provides necessary thing. So right now, we don't have to take what is happening in the country as a change or anything. It's a manner in which things are being done are modified to the extent that in those areas where private companies can generate their own earnings and invest, they will do. And in parallel, government will find new ways of enabling them, because these are like today, if you see the performance linked incentive schemes and all that for various things which are provided. So here also, when investment requirements are huge, there will be less private enterprise which will come. So government is trying to provide many of the facilities that are available at ISRO for use by these companies, so that their expenditure on the development of the facilities are reduced, so they use it as a service. So this will be a continuing process where India as a whole is what is being looked at by DOS, and DOS will enable more and more people to participate in space program. And in terms of research, if tomorrow, for example, you have to develop renewable vehicle, means energy, if you want to use solar energy, unless your cost of access to space is reduced, you cannot do that. It's not economically viable. So you will start worrying about how to build such re-entry vehicles, and then bringing down the cost of launch, etc. So a lot of research work will go on. So the Department of Space job is now not just what was happening within ISRO. Now it is what is happening in the entire country, enabling it for the benefit of the country.
Yeah, so we have, we can take perhaps.
There is one question,
yeah,
one lady there.
That, please.
Hello, sir. Thank you for the very informative talk. I have just one question. As the space is entering into new sectors, I just want to know what are the plans of ISRO or the space program to enter into the climate change? Basically, the satellites monitoring the greenhouse gases or aerosols. Because we have the reanalysis products already available. So what are the plans related to this climate change in the future? As we are using more and more products from different countries, when can we expect such a product to come in India?
Yeah, it's a challenging question. See, today one of the thing is, in terms of climate change studies, etc., whatever information that can be gathered from space missions, if you look at in the immediate future, there is no specific mission where this is planned. But there are missions where you are looking at hyperspectral imaging from space. One of the things from geostationary platform operating in visible infrared and far infrared with many wavelengths, and using at narrow bands, making observations. There is a mission, but when it will happen, we'll have to wait and see. But today, what is being done in the country is being a partner in many of these international space programs, providing the data which has been picked up and then making it available to the community within the country, both with Bhuvan in NICES in NRSC to MOSDAC here in Ahmedabad. The effort to make this data available to the research and scientific community is going on.
So, sir, this session is live in YouTube also, and some of our viewers have posted their questions. So, I request Durga to read a couple of questions. Yeah.
Good evening, sir. So, there are a few questions from YouTube online platform. So, in the interest of time, I'll take a few ones. So, the first one is that it is interesting to see that Brazilian space program heads always begin their presentation with a slide with the Sarabhai statement and his vision to follow as a developing country. However, we have not had any long-term collaboration in space technology except one recently. So, do you foresee any long-term collaborations with Brazil in future, and in which domain probably?
With Brazil?
Yes.
Okay. Okay, what happens in any international collaboration is a mix of many things. How the people, the collaborating groups, and how the collaborating groups are supported by the respective governments. Otherwise, there have been many discussions which have happened, and even as part of BRICS also, there have been discussion. And in fact, India was providing to the Brazilian ground station data from our remote sensing satellites. And even now, I think one of the satellite data is downloaded in the Brazilian ground station. But then how any collaboration between two countries takes place is too wide a scope for me to comment on.
Thank you, sir. The next question is, sir, what do you think will be the next biggest technological advance in space research and space science in our country?
In our country, okay. No, in terms of technology, if you see, one of the things, for example, while the discussion was going on, see, today there are companies which are building 3D printed engines. Even globally, if you look at 3D printed engines operating is still not a thing. So, when you are able to do 3D printed products, both in terms of the timeline and the cost, etc., you are bringing down significantly. And in fact, here is where the answer to one of the questions that he was asking earlier, that while the government, the speed with which it can deal with change requirements and new investment, and the speed with which a private enterprise can operate is the difference that is there. So, in terms of technological breakthroughs, if you see, making reusable launch vehicles, which Elon Musk has already demonstrated many times. He has brought back the first stage and done. The more and more reusability is one that is going to make a difference. And the second thing is in terms of the speed at which we are traveling in space. That is, of course, more for traveling in space rather than applications on planet Earth. For planet Earth application, even in terms of energy, the next most important aspect is to bring down the cost of reaching to space and setting up facilities there. And if that cost comes down drastically, then it makes a huge difference.
Okay, thank you, sir. Probably last question. Every mission from India, although does on a smaller scale, is having an imprint, maybe Chandrayaan-1, Mars mission, or radars and so on. Do you attribute to the leapfrogging approach, or is there any other thing behind it?
No, what I would only think is that people who had to do these activities, they operated within the constraints of the resources that were available to them, and they conceived of solutions which were relevant to the society and important, which needed to be done. So like if you see, initially it was communication, weather, monitoring, etc. So then progressively increasing on their capability. So leapfrogging primarily is only meant to say that conserving all the resources you have, how you can demonstrate your capability to achieve the target you are setting. Otherwise, if you have enough resources, you can build up momentum running so many meters before you take a jump. So leapfrogging is in that sense an activity which has happened and which has helped India.
Thank you very much, sir.
So thank you, Durga. So now we are closing this interaction and question answer session. And sir, thank you again for your valuable time to our audiences. Thank you. Now, let's continue session.
Thank you very much, Professor Lokesh and Dr. Durga, for conducting this session, and thank you very much, sir, for answering all the questions. We could have some more questions, but there is scientific meeting is lined up for him, so we have to. Sir, please be seated for 2 minutes. So we have to stop it here. My apologies for not carrying on with other questions. Now I'll request our director, Professor Bhadkamkar, to kindly honor and felicitate today's Vyakhyaan Karta, Shri Kiran, for this wonderful Vyakhyaan, and more importantly for all the great troubles you took. That was really great. You read his original writings. So will you please? It will good.
Can you come here? Thank you for a very excellent talk.
Now the last string in the chain would be the vote of thanks. But before vote of thanks, I'll make 2 announcements. That after the vote of thanks is over, kindly be seated for 2 minutes. We'll have a picture, we'll have a photograph in the same position, seated here. So please spare 2 more minutes after the vote of thanks. And thereafter, we request you to join for the high tea. So now I'll invite Dr. Bhushit Vaishnav for presenting the vote of thanks. Thank you so much.
Thank you, Professor Deshpande. Thank you, Kiran Kumar sir, for a fascinating talk. And Happy New Year to all of you who are present here and who are watching us live on YouTube. Today's count for the lecture, which is attended by all of us sitting here plus YouTube, is crossing 600. Yeah. So the participation is still continuing, and hence the Vyakhyaan series is continuing. At this juncture, and as the topics, the diversity of topics just presented a while ago, a few lines are reminded to me, and I'm trying to share those lines with you. चमन में इख्तिलात रंगों से बात बनती है, हम ही हम है तो क्या हम है, तुम ही तुम हो तो क्या तुम हो. What we are trying to say here is, it is the intermingling of colors and fragrance of various scientific as well as other topics which made this Vyakhyaan series so live and so interactive. And for that, we would like to once again thank a galaxy of speakers, and I would like to present them one more time on the screen for every one of us to see them again, and a large round of applause for all of them. Some of these Vyakhyaan kartas or speakers gave Vyakhyaan at odd hours, not so routine working hours. Some were talking to us early in the morning or late in the night, like 11 o'clock or 12 o'clock. So we are really thankful to all these Vyakhyaan kartas, and also agreeing to our request without any further formalities or protocols, and just saying yes, that I will deliver the Vyakhyaan. So we are really thankful to all the Vyakhyaan kartas. I must thank at this point all the PRL faculty members, current as well as superannuated, for helping us in finding some of these Vyakhyaan kartas and helping us in contacting them and bringing them to this forum. We are thankful to them. We must thank one more time, as it was said earlier also, our director, the beacon of this Vyakhyaan series, and our dean, Professor Palram Raju, for their constant efforts and encouragement in keeping this show going. Of course, I must mention special thanks to our present registrar and our chair PPG, Professor R.D. Deshpande, for all his support and encouragement for all the time. I would like to thank few of my colleagues in registrar's office and director's office and dean's office for helping us in running the show uninterruptedly, even though some of us were not present for various reasons at some point of time. The show continued with their help and support. Thank you to all of them. Soon we are going to come up with a compilation of all the 75 Vyakhyans through a coffee table book, for which the work is already started, and we thank in advance the team purchase, the team accounts and team computer center for all their help and support which are going to be there in this upcoming work. As the entire series, the 75 episodes, were conducted live online using online platforms, that is YouTube and WebEx, we must here mention special thanks and recognition to our CNIT team, who helped us in keeping the bandwidth available to us on every Wednesday so that these lectures continue without any problem. So we thank all the members of our computer center for their kind help and support. Last but not the least, if I am forgetting anyone in sitting here or not sitting here, I thank each one of us for their help and support. Special thanks and special mention to the dignitaries and invitees available with us today in this forum. Some of the faces which you are seeing on the screen are present in the audience today. They are our Vyakhyaan kartas, they are live today, they are with us, and we would like to interact with them more in future in person. We had invited several guests from our nearby places, Space Application Center, Gujarat University, IIT Gandhinagar, and some of them could manage to come in spite of their busy schedule. We are thankful to them. We are thankful to our senior faculty members who are with us today. Thank you all for coming and joining us on this occasion. And last but a very important thanks to the entire Pakao committee. We call it PKAV, Pakao committee. It is an abbreviation on a lighter note. But we got a fantastic teamwork, and teamwork is the spirit of PRL. This is my 14th year in PRL, and I am seeing that any event, whether it is of this nature or any nature, is running without any problem, and that is the culture of PRL, which probably Sarabhai has imbibed in all of us. With this, I conclude, and thank you once again. And I invite all of you for high tea outside the tea. And please stay back for the photograph as it was announced.